Today is I'm going to run through the front of this worksheet that I left with the sub that says solving trig equations. So this would have been the lesson I would have done in class today. So I'm going to run through the front of the worksheet, and then the back of the worksheet, which is your homework, is very similar to the front. So you guys should be able to model what I'm doing now onto your homework. First thing I want to do is start with the first one. It says, find all value of x in this interval, 0 to 360, that satisfies the equation 5 sine x plus 3 equals 3. Now, one of the reasons why we had you guys do last night's homework was to help prep you for this lesson, the solving part in the back. If I take this equation and wrote it like this instead, how would we solve this? We would subtract the 3 over to the other side. We end up at 5x equals 0. And then we'd want to get x alone, so we would divide by 5 and get x equals 0. Well, we're going to do this one the same way. The only difference is, instead of it looking like this, there's a trig function in it. So let's take a peek at this now. I'm going to rewrite it. 5 sine x plus 3 equals 3. Well, just like I did here, I'm going to subtract 3 over to the other side first. Subtract 3 over. So I get 5 sine x equals 0. Well, the goal is to try to get x alone, so I'm going to divide by 5 just like I did in the other equation. So I end up with sine x equals 0. Now, while this question was done because we got x alone, we still don't have x isolated here. There's a trig function attached to it, so there's something we have to do. What this is saying is, when will sine x equal 0? Now, here's the deal. If you get 0, 1, or -1 as an answer for sine or cosine, you want to think of the unit circle. All right, this is the point 1, 0. This is point 0, 1. -1, 0. 0, -1. Where on the unit circle is sine going to be equal to 0? Well, since sine's the second number, sine is 0 here at 0 degrees, 360 degrees. Sine is also 0 here at 180. So here we go. We have answers for this now. Sine equals 0 at 0 degrees, 180 degrees, but I'm not going to put the 360. And the reason why is there's no line underneath here on my inequality. That means we're not including the 360. So those are the two answers for the first question. All right, so we're going to build this a little bit. Now we're going to do it with tangent instead of sine. So let's take a look at this equation. 4 equals 5 minus 2 tan x. So just like I solved this one, we want to try to get the tan function alone with a number. So I'm going to subtract the 5 over first. So I get -1 equals, don't forget this little minus here that counts, -2 tan x. Again, I want to get the tan x alone, so I'm going to divide both sides by -2. So this leaves me with 1/2 equals tangent of x. All right, now I need to know what angle would make tangent equal to 1/2. Now, I'm going to go to my graphing calculator for this, or any calculator for that matter. Turn it on. The way we try to figure out what angle creates something is we use the tan to the -1 button. So let's make sure you guys can see this here. So you're going to hit second tangent, and you see it says tan to the -1 up here on the screen. Then I'm going to type in 1/2 and hit enter. And what I notice, I get this weird looking answer. That means my calculator is not in degree mode. So I'm going to make sure I put it back in there. And I'm going to do it again. Second tangent. So it says tan to the -1. So anytime I want an angle, I'm going to go to the -1 function of my calculator, and I'm going to put in the 1/2. And this time I get 26.565, and it says I want to round it to the nearest degree. So that gives me 26 degrees. Now that's not the only answer, or it may not even be the answer. We have to take a look at this. How many quadrants is tan positive in? And I want to know where tan is positive because this is a positive 1/2. Well, if I do ASTC, tangent's positive in the first quadrant. That means I'm going to draw 26 degrees in there. Tangent's also positive in the third quadrant, so I'm going to draw 26 degrees in there. From here to here now, that distance is 26 degrees. That's going to be one of my answers. And then from here to here is 206, and that's the other answer. So x equals 26 and 206 degrees. All right, we're going to step it up a little bit. Now this one is giving us a quadratic. 2 sine squared x plus sine x equals 1. So I'm going to rewrite that here. Now, before I do this, I'm going to rewrite it again like I did before. What if I gave you 2x squared plus x equals 1? So I'm basically rewriting this equation without the sign in it, just to get an idea of what's going on. If we had this, what would our first step normally be? And I'm hoping you're all saying, set it equal to 0. So that's what I'm going to do. Just like we would have set this guy equal to 0, because this equation has a squared in it, I'm going to do the same thing. I'm going to set the equation equal to 0. Now, this is where we have two options, right? Normally here, we'd either factor it or use the quadratic formula. I honestly think you guys should always go with the quad. It's safer. Sometimes you guys like to factor things that are unfactorable. So I'm going to jump back over here and let's try it with the quad. Just like over here, where you would have said A is 2, B is 1, C is negative 1, we have the same deal here. A would be 2, B would be positive 1, and C would be negative 1. So let's throw that into a quad. So we're going to do negative 1 plus minus 1 squared minus 4 times A times C all over 2 times A, which makes negative 1 plus minus. Right now we can put this in our calculator, make sure you guys are doing this right. Parentheses 1 squared minus 4 parentheses 2 negative 1. This becomes a 9 over 4, which makes negative 1 plus minus 3 over 4. So now we have a couple of possibilities. So now we're going to jump over here, take negative 1 plus 3 over 4, negative 1 minus 3 over 4. So this makes 2 over 4, which is 1/2. This makes negative 4 over 4, which is negative 1. But those aren't the answers yet, because it's not x equals, this is sine x equals. So that means I have sine x equals 1/2, sine x equals negative 1. All right, now here we go. If you've got 1, 0, or negative 1, you want to go back up to the unit circle. Where on the unit circle is sine equal to negative 1? And if you notice, that happens at 270 degrees. So x equals 270 is one of the answers. Now we're going to deal with this guy. Sine x equals 1/2. I need to know when that happens. So I'm going to do sine to the negative 1 and type in 1/2 into my calculator. So I do sine to the negative 1, I put in 1/2, and 30 degrees pops out. Now that's my reference angle. That is not my answer yet. What I have to do is figure out what answers come from that reference angle. So I need to do ASTC. Since that was a positive 1/2, I'm going to draw that 30 degrees in the two quadrants where sine is positive. From here to here is 30 degrees. That's one of the answers. And it won't always be the same. Sometimes it's not the same. We'll talk about it in a minute. And from here to here is 150. So this answer, this question actually has 3 answers. 1, 2, 3. All right, let's kick it up a notch. Let's do a cosine one with a secant mixed in. All right, so I got 5 cos x equals 2 secant x minus 3. Now here's the deal. You cannot solve one of these things if it has two different trig functions in it. So we have to change one of them. And I'm hoping you remember that secant is really 1 over cosine. So right here, I'm going to type in 1 over cosine. Now, since this is a fraction, I'm going to make 2 look like a fraction. So that becomes 5 cos x equals 2 over cos x minus 3. Now, this is a fraction, so we're going to make everything look like a fraction. And now we need a common denominator. And my common denominator here is going to be cos x. So this guy needs a cos x, so the top needs a cos x. And the bottom needs a cos x, so he needs a cos x. Right? So now we have 5 cos squared x equals 2 minus 3 cos x. And I'm allowed to drop the denominator because there's an equal sign in the problem. So all those old rules still pop up from solving equations. So now we have this sucker. Now, it's a squared question. So if it's a squared question, you want to set it equal to 0. So now I'm going to subtract and add these guys over to the other side. All right. Make sure you guys can see this. So I end up with 5 cos squared x. Now we're going to go to the quad. A equals 5, B equals 3, C is going to equal negative 2. So I'm going to do negative 3 plus minus 3 squared minus 4 times 5 times negative 2 all over 2 times A, which makes negative 3 plus minus radical something over 10. So I'm going to go to my calculator. I'm going to type that in. 3 squared minus 4, 5, negative 2. Notice I'm putting parentheses around everything, and that makes 49. So I get negative 3 plus minus 7 over 10. So now I have two possibilities. Negative 3 plus 7 over 10, negative 3 minus 7 over 10. So this makes 4 over 10. That's not a 10, it's a 5. 4 over 10. So that's 2/5. And this is negative 10 over 10, which is negative 1. So now, these are my two potential things we're working with. I've got cos x equals 2/5. Cos x equals negative 1. Okay, so we're almost done. Anytime you have sine or cosine equal to 1, 0, or negative 1, we go back to our unit circle to find the answer. Where on the unit circle is cosine equal to negative 1? And I hope you notice here at 180. So here we go, x equals 180 degrees. So this is the answer that goes along with this guy. However, for this guy, we've got to use our calculator. So you're going to type in cos to the negative 1 equals 2/5. So go to calculator. Right. Cos to the negative 1, I'm going to type in 2/5, and I've got 66.4. Since I want to round it to the nearest degree, this is now my reference angle, not the answers. Since that was a positive 2/5, I've got to draw the 66.4 in the two quadrants where cosine is positive. So I'm going to go from here to here. That means x equals 66.4 degrees. And then from here all the way around to that line would be 360 minus 66.4, which makes 293.6 degrees. So just like the last question, there are 3 potential answers. Now, I do want to do one more of these with you guys. Right? You can squeeze it in on another piece of paper. I want you to see something. What happens when the fraction you get is not positive? So let's say I'm going to do an easy one. Let's say I get want to solve for x, and we're going to go between 0 and 360, right? We're going to round to the nearest degree. And I'm going to say let's do 3 sine x plus 2 equals 1. So let's say we want to solve this guy. Okay. Notice nothing squared. If there was a squared in it, we'd set it equal to 0. But it's not. So this is what we call a linear equation. So all we want to do is solve for sine x. So these are gone. 3 sine x equals -1. Just divide by 3. So I end up with sine x equals -1/3. All right. Now, had this number been 0, 1, or -1, we'd look on the unit circle for the answer. However, this is a fraction, so fractions mean we need the calculator. Now, when you go to the calculator, you do not put the negative in there. You're going to do sine to the -1, and you're going to type in +1/3, because what we need to know is the size of the angle. The negative we're going to bring up later. So I'm going to do sine to the -1, put in 1/3, and I'm getting approximately, we want to round to the nearest degree, so I'm getting 19 degrees as my reference angle. This is the reference angle. The negative now is going to come into play here when I do the placement. A, S, T, C. This time we had a negative fraction. So we're going to put the 19 degrees in the quadrants where sine is negative. So that means I would put a 19 degrees there and a 19 degrees there. So from here to here would be 180 plus 19. So that answers 199 degrees. And this answers from here to that line, which would be 360 minus 19, which is 341 degrees. So anytime you get a fraction that is negative, when you do the calculator part, do not put the negative in your calculator. You leave the fraction positive. The negative helps us with where to place that reference angle, and you get the answers from there. All right, so your homework now for tonight, or for the weekend, is to do these questions. All right, now, when you look at this one, is there anything squared? No. So you're going to move him over to the other side and then use your calculator to help you get the answer. Same deal on the next one, number 2. Is there anything squared? No. So you're going to try to get the cos x alone. Look at this one here, number 3. Ooh, there's something squared. So you want to set it equal to 0. Oh, it is set equal to 0. So now you could just go right to the quadratic formula, go from there. And then the last one has something special going on. 2 sine squared x plus 3 cos x. These are not the same. They're different. So we're going to have to change one of them. In order to do this question, you guys need to watch the other video I had on there that said solving trig equations requiring substitution. You're going to have to use one of your Pythagorean identities, and let's face it, the most famous one, sine squared x plus cos squared x equals 1, in order to solve this question. So watch that video first, then come back and try this sucker. So do your best you can over the weekend. Try these. When I come to class on Monday, we're going to go nice and slow through these. And I'm hoping you guys filled out the front. Now remember, if you missed it, just replay the video and you guys can do it again. But these are good ones to practice. And I hope you wrote down the one in the back too, because that was a great one as well. I didn't think of it last night when I typed up your worksheet. All right, see you guys all soon. Bye-bye.